Hello guys, this is Terry from Dev Screencast. In this video, you're going to learn about Docker and how to use it locally to develop different type of software. If you don't already know, Docker is basically a tool that was designed to make it easy to create, manage, deploy, and run applications by using something known as a container. A container allows us to basically package our code and all of the dependencies that our code needs to, or our application needs to run properly into an isolated environment that can be run on any platform. So this is really something that is amazing. And if you take a look at the survey from Stack Overflow from last year, and even I think the year before, it was 2019 and also 2018, you see that the popularity of Docker has really grown over the years. So we're going to learn how to install the software, how to use it locally, and subsequently we'll be using Docker to develop applications, because this really saves us a lot of time and also a lot of having to manually install different software on our computer. So for example, if we want to write a software with Node.js or PHP or even Java, instead of installing all of these different pieces of software and database on our computer, we can just install it in a container. And if we decide that we no longer need any of this, we can just delete that specific container and our computer is still as clean as it was before the installation. So this is really a big deal, and I hope that you're going to enjoy this video as we ride on. So the first thing we're going to do is to actually install Docker on our computer. I am on a Mac operating system here. The process is fairly the same. On Windows, you may have to fulfill some other requirements, like the type of window environment that you can actually install Docker on. So that will be on a separate video, but we're going to focus on installing Docker on a Mac right now. All right, so you have to navigate to docker.com, and right here we're going to click on Get Started. And I'm going to click on the button here, Download Desktop and Take a Tutorial. So we're going to click on that. Takes us to the Docker Hub website, and this is going to require us to actually log in. So to proceed, you need to create a Docker ID if you don't already have one. I already have one here, so I'm going to sign in. So if you don't have a Docker ID, click on sign up and then create an ID, and then continue to sign in. And from here, I'm now going to download the Docker application and then save it to my computer. So that will take some few seconds or minutes to download, and I'm going to pause the video while it is downloading. The installation has now completed. I'm going to open the installer. And the only thing that we need to do is to basically just drag this installer to the applications folder. So I'm going to drag and drop, and then I'm going to open that from the applications folder. So I can basically search for Docker, my applications folder, and then open that. I'm going to click on open. And with that, we should have Docker running right now. So if you look at the menu bar at the top here, you can see that it is trying to start Docker desktop. So it may take a few seconds to get it started, and in some cases, we may be required to grant some permissions. All right, so Docker is already running right now. And if we want to stop it, we can come here and say quit Docker desktop, or we can restart. And we can also sign in here using a Docker ID, which is the one that you created before you were able to download. So what we now want to do is to open our terminal. So any command line tool that you're using, I'm using item, I'm going to open that. And right now we're going to learn about some basic Docker commands. So we don't yet have anything running on Docker. We only have just finished installing Docker. So first thing I'll do is to type Docker and just hit enter. This is going to display a list of commands that I will be able to execute with Docker. And so once you look at the specific command, you also see a description of what you can do with that specific command. So we're going to be using some of this, not all of them, in this crash course, but subsequently we'll also learn about the other commands. But we'll be using a few of these commands in this video. So if we also want to learn something more about specific command, we can actually type out that command and ask for help. So when we do that, it also gives us information in detail about that specific command and the options that we can use along with that command. I mentioned previously that Docker allows us to package our code and all of the dependency into a container. And basically, the way that we achieve this is to basically create something known as an image. An image is actually now those softwares or those dependencies that we need to actually run our software. And when we run an image, it becomes a container. So you can think of as an image as a class. If you're writing in Java, you have a class, so an image you can think of as a class. And then the container is just when an environment where we actually run this class. So we're going to start off with some container that are already existing in Docker Hub. So basically, Docker Hub is a repository where you can find all of the images that you have pushed remotely or images from other developers. So our first task would be to basically use one of the images that are from Docker Hub to illustrate what I just explained just now. So we're going to say Docker container run. So we're basically saying we want to run this image, and this is going to be the Alpine image. When we type this command, we can also optionally specify what command we want to trigger. So I could say, tell me what's the host name. So what we have here is the Docker command line 2, and then we are executing the container option, and under container we are executing the run option, and we are saying we want to run this image called Alpine. We don't have this image on our local machine, but this image already is existing in Docker Hub. So I'm going to click on enter. The first thing it does is try to find this image locally. Since it doesn't find this image, it goes on to Docker Hub and pull in this image. And you can see here that it's pulling from library Alpine. And that has now completed. So basically what it did was to execute the host command. So we could actually just do that again with a different command and say this time we want to ping www.google.com. Since it already have this image locally, there was no need to pull it remotely anymore. So it's now running this image on my local machine right now. So what I will do now is to press Command C to terminate that. And the next command that you're going to learn about is still also Docker container. Let's start by doing --help to see a list of all of the available options. And right here you can see all of the options: attach, commit, copy, create, diff, exec, and also the ones that we just used, run. So we're going to issue another command. So that will be Docker container ls. So this is going to list out the container that we have. And right now we don't have any container. We could also add an option to that, --all, and it shows us the Alpine image that was being executed. So this container was the one that we just finished executing. You can see right here that basically this was a command that we issued. First one was hostname and the second one was ping. And you can see the image is Alpine, you can see the container ID, you can see when it was created, and the current status is exited, and for how long? For about 48 seconds, and this was about 48 minutes ago. This was not running on any port, and Docker implicitly created names for these containers. All right, so the difference should be clear now. We have an image which is called Alpine, and when we run this image, it becomes a container, and that is what we have here identified with the container ID. So a couple of more things that we can actually do with the container. Let's learn some few more commands. So we could also type docker container run. We want to run this interactively, so we can say dash IT or dash dash interactive. So let's see which option is that. Let's say dash dash help and see what are the available options. Okay, so here we have dash I for interactive and dash T to give us access to a pseudo TTY. So we're going to execute that and say dash IT, which should be short form for saying interactive and TTY. Okay, and we can also do dash rm, which means once we finish with this container, we want it to be removed. Okay, so the previous container, we did not remove it, we just exited out of it. But right now, adding this option dash rm, it means that once we are done, we want this container to be removed. And the image that we're going to use will be the Ubuntu image. So let's say Ubuntu, and we basically want to run bash. All right, so we have docker container run dash it dash rm Ubuntu. It's the image. So remember, this is the image that we want to run right now. And the command that we want to run on this image is bash. So I'm going to hit enter. It's unable to find Ubuntu image locally. It's going to pull it from remote. And that is now complete. So you can see right here that we are in the command prompt for the Ubuntu operating system. So what we just did right now is to basically install Ubuntu in this container. And then we can do all of the stuff that we can do on Ubuntu operating system right here. So for example, we can do ps-us to see the processes that are running on this Ubuntu operating system. We can run cat /etc /issues, and we can also do ls. So basically you can see that we have a full-blown operating system right here. So when we, for example, are going to run a PHP application, what we basically need to do is to build up an image which branch off from either the Alpine operating system or Ubuntu operating system, and then install PHP on this operating system, install all of the other extensions that we need to run PHP, and also install a web server. And once we do that, we can now expose some specific ports and be able to have access to this machine from the outside world. So what we can do now is to type exit to get out of this environment. And just to show that Docker doesn't basically keep this last container, we're going to do ls-all. And you can see that we still have two containers here. The third one is not listed here because we use the -rm option, which is basically saying once we exit out of this container, we want you to basically remove it. We don't want you to keep it. So there are times where we want to quickly get information about the specific container. So what we can do is to basically look at the log file. So Docker gives us a pretty basic command to examine the log file of any container. We can do that basically by using the container ID or the name. So for example, we have the name here, determined underscore Turing. So I can copy that and then just paste it here. And when we do that, you see that it gives me a log of what was going on inside of this container before I exited out of the container. And we can also use the rm command to explicitly delete a container. So we could basically say docker container --rm, or actually we need to say rm and then give the container ID. So let's remove this one. Let's come here and then paste it here. And then if we type docker container ls --all, see right now that we have only one container running. So if the container was still running, you would not be able to basically delete that container. And what you need to do in that case would be to first of all stop the container using the docker container stop command. So that will be docker container stop, and then followed by the ID of the container that you want to stop. And that will essentially now allow you to do the next step, which is to remove that container. All right, so let's move ahead. We can also use a different command to inspect. We can say docker image ls. And this tells us that we basically have two images here. So we have the Ubuntu image and we also have the Alpine image. So these are two images that were downloaded to our local machine. And with this and whenever we run this image or whenever we use this image, a container is being created for us. So that's just the simplest way to explain this. The image represents the code or the software, the applications that we are bundling together, including their dependencies. And when we run these, it becomes a container. And in that container, we can do all of the stuff that needs to be done. So we're going to see like some pretty basic examples. But before we do that, we're going to pull in one more image. And this time we're going to try to run the MySQL image. So basically, I'm going to be going in direction of PHP in this basic tutorial that we're doing. Even if we're not going to be going into details, but let's just say that we are going to run PHP. We need MySQL database to run PHP. So I'm going to say docker container run. I would say -d. So the -d option basically means that I want Docker to run this container in the background. So the difference between this and not having the -d option is if you don't run this container in the background, then it will keep running on the terminal here and you will see the logs being displayed in the terminal right here. But if we choose to run it in the background, then we can continue to do other things in the terminal. And then we can basically say we want to name this by ourselves. Remember previously Docker created names for us by itself. So I could say MySQL DB. So let's follow the same format. MySQL underscore DB, which is going to be the name of the container. And then I can say -e, and -e option here basically means that we are going to be using environment variable to specify some information. And the information that I want to specify will be the password of the root user of MySQL. So I'm going to say MySQL underscore root underscore password is equal to Let's just say secret. And then we now specify the image. So we could specify the image by just typing MySQL, or we can also go one more level to specify a tag. So if we specify a tag, it is going to install that specific version for us. So if we don't specify anything, it's always going to install the latest MySQL image from the Docker Hub repository. So I'm going to quickly show you this. Let's go to Docker Hub. So we're right here on Docker Hub. I'm going to exit out of here, and then I'm going to search for MySQL. So you can see the MySQL, official MySQL image right here. And right here, you can see basic command, just like the one that I typed on the screen right here, which essentially is doing the same thing, but now specifying a tag. So let's see how we can get more information about the tags, and you can see here the different tags that are available. So if we want to install MySQL 5.7, we're going to pull in the 5.7 tag. If we choose to install the latest, it's going to install MySQL 8 on our operating system. So what I'm going to do is to install 5.7. So I'm going to say 5.7. Then hit enter. It doesn't find it locally. It's going to pull it now from Docker Hub repository down to our operating system. So this is taking some time to pull in. It's always usually like this the first time that you're trying to pull in an image, and then when next you try to pull in this image, it becomes very fast because it will be pulling from the cache. All right, so we now have MySQL image on our computer. So I could say Docker image ls. And you see here that we have MySQL and the tag is 5.7. And then what we can do next is to basically also inspect our containers. So let's say Docker container ls -- all. And you see now that we also have MySQL 5.7 running, and you can see the name is the name that we gave, and something that we didn't see before is the port. We can see that MySQL is running on port 3306 TCP, 33060 TCP. So if we wanted to access this MySQL database from a client like Workbench or SQL Pro or PHP Admin, this will be the port that we basically need to connect to. So let's try to execute a command. So we've not seen this before. This is called docker exec. So basically docker exec allows us to run a command inside of a container. So what we're going to, the command that we want to run now will be basically to log in and check the version of MySQL that we're using from the container. So we can put the -it tag to make it interactive. And then we can specify the name of the container. So that will be MySQL _db. And then here MySQL. And we then need to specify the user and the password. So user will be the root, and the password is just going to be the password that we created a while ago. So this should be --user. And we can say --password is equal to. Okay, so this is where we're now going to do something really interesting. Remember when we basically run the container for MySQL, I made mention of the -e option, which was, I said, was used to specify that we'll be getting the specific information, which in this case is the database, from the environment variable. All right, so we have this environment variable here called MySQL root _password. So this is now existing inside of the Docker container. So we can access it the same way that we access environment variable on our computer. So we can say the password is MySQL underscore root underscore password. And this would now basically resolve to the password that we specified, which is secret. Okay, so I'll show you a way that we can also verify that. And then we can say dash version if everything works correctly. It should tell us the version of MySQL that we're running. So we can also check for logs. So we can say docker log MySQL underscore DB. So this will give us all of the logs that are available inside of MySQL. And something to take note of is that right now MySQL is running in the background. Okay, so MySQL is running in the background because we use the -d option. That was just a basic introduction to using Docker. So you now know how to play with some basic Docker commands. There's still a lot of things that needs to be learned, but now we can go ahead to the next level. We are going to try to just package and run a custom application using Docker. So to do that, I am going to have to make a new folder here. So I want to make a new directory, or I should already have a directory called Docker. Let's see. Okay, I don't have that. So I'm going to make a directory, and then I'm going to call this Docker. In this directory, I basically have all of the Docker project right here. So I'll cd into that directory, and then I'm going to make another directory, and this is going to be custom underscore app. All right, and then I'm going to cd into custom underscore app. Then I'll just clear the terminal. So basically what we want to do now is to be able to build our own Docker image. All right, so previously we've been using just images from the Docker Hub repository, but right now we're going to be able to build our own image. And for that, I'm going to basically open VS Code, which is my test editor. You can use whichever test editor you prefer to use. I'm going to open a folder. Okay, so that should be under my user. Then that should be Docker, and then custom app. Right, so that's a very empty folder. We don't have anything inside of this folder. So the first thing I want to do right here is to create a file. And the file that I want to create is called a Docker file. So when we need to build an image, we need to create a Docker file and then write some code inside of this file, or basically give the specification of the image that we want to be created. So this is one way to create an image that we can use to start up different containers. Another way would be to also use something called Docker Compose. So that's a different kind of file that we can also use to create Docker images. So the first thing I'm going to do here is to type from, and then I'm going to say from Nginx. So Nginx is basically a web server, and we want to get the latest. So remember, from what we did previously, we specify the name of the image that we need and also the tag. So if you need a specific Nginx image, you need to specify the tag, and I already showed how to find this tag. You go to Docker Hub repository, look for the image, and then look for the tags under that specific image. And right here we are going to, okay, so let's start from just explaining what this from command does. So we are saying from this specific image, so this image called Nginx, the latest one, is going to be our base image. So we are saying use this as a starting point to create the new image that we want to create. All right, and then the next is to basically copy some files into that image. And the file that we want to copy, let's call this index dot maybe PHP or HTML. So let's call this index.php. We don't have this file yet, but we are going to create this file shortly. Then we're going to copy this to a specific folder. So that will be user/share/nginx. And then we can basically say put it in this folder called HTML. Okay, so let's start with HTML. And then next we can move to PHP. Okay, so we're basically saying copy index.html from the root directory wherever this file is located. So we don't have this index file yet. Maybe we're going to just quickly create that. So let's say index.html. And basically what we're saying is just copy this index file into the container inside of this folder called HTML. And then what else we can do is to expose a specific port. So in order to view this from the web browser, we need to expose a port. And basically we can expose port 80 and also 443 if we have HTTPS. And then finally, we are going to specify some default commands. And I will explain what this means shortly. So the first default command that we want to specify here will be nginx. Then we can also pass it some option. That's G. And then we want to say daemon off. All right, so expose basically says which port this application is going to be using, and cmd is the default command that should be run when the container is started. Okay, so if you remember previously, when let's go again here and just say docker container ls -- all. And right here, you can see command. So basically, when we run a container specifying a command, that command will be taken as the command to start up the application with. But if we do not specify a command, then the default application command will be used to start up that container, and which is what we are just specifying here. So we're saying for this image, when we try to start up a container from it, we want you to expose or run this specific command. Then we can basically save that. Okay, so let's come to our index file, and right here we are just going to have an h1. Let's say an h1 and then say running docker app. And then we're going to save that. All right, so now we have a Docker file and we have a source code that we want to build a container off of. So we basically now need to, first of all, create the image. After we create the image, then we can basically use that to run a container exposing a specific port. All right, so let's see how we may basically do that. So first thing we need to do will be to type docker. This time we want to use a different command called build. Okay, so we are basically going to build a new image. All right, and don't forget what I said previously. We are building this image right now, but the base image is basically nginx. So we are saying nginx is the base image of this new, is the base image of the new image that I want to create. Okay, so that should be image because we want to build an image. And then we're going to specify a tag. And then we are going to basically just give this a name. So the basic format for naming your images will be your docker ID / name of the image column a tag. And to make this a bit easier for us, we can basically just export our docker ID. So we can say export docker underscore ID, and then mine will be Tedia07. I don't know why I cannot remember my password. Basically, I was trying to log in. So let's come here and see. So it's basically Tedia07. Let's see. All right, so Tedia07. So this is my Docker ID. I'm just going to export it to my environment so that it's easy for me to just use this environment variable instead of typing Tedia all the time. All right, so we can basically just echo that now. So we can say echo docker ID, docker underscore ID, and that gives me my ID. So now we can say docker image build, and then we say give it a tag, and I'm going to use my docker underscore ID slash custom. Let's say custom HTML, and then I'm going to give it a tag. Let's say 1.0. All right, so what we are doing here is basically saying, look at the root of this folder where I am currently. Okay, so the folder that we're using currently is called custom app. We are saying right now, look at custom app, look for a Docker file there. Okay, and using this Docker file, I want you to build an image, and I want you to name that image using my Docker ID slash custom underscore HTML and tag it 1.0. All right, so to tell it that we are saying look at the current directory, we need to put a dot here. Okay, if you don't put this dot, then it doesn't really know where to find this file that we want to use. Alternatively, you can also use the -f option to specify a Docker file that you want to use to build your image. But right now we're just saying use the context. Okay, so the context basically says the current working directory, and we're going to hit enter and say sending build context to Docker demo, access denied for Nginx. Repository does not exist. So which means that I basically have a typo in the name of the Nginx. Yeah, I got a typo there. So let's come here and then quickly fix that. So that should be Nginx. Yes, Nginx. And going to correct all of this. I'm going to save and then build that image again. Okay, so now it's copying from Nginx latest. And it's going to basically just build up that image on our local computer. And after we do that, we can then use the Docker command to basically run this image. All right, so what we want to do now is to basically run the image. So we're going to say Docker container run, which is what we've always done before. Okay, Docker container run. This time we want to detach it. So let's say -d. And then we want to say --publish. Or maybe we can also just use the full option here. We have been using -d. So let's say --detach --publish. And basically what the publish here does is it allows us to specify a port that we want to use. So remember, in our file here, we're exposing port 80 and 443. Okay, so we're going to now say we want to map port 4000 to port 80. So 4000 will be the port that we use externally, and 80 will be the ports in the container. So we can also just say 8080. You can use any free port, doesn't matter. Then we can say dash dash name. And let's just call this custom HTML. And then finally we can then specify the image. So the image that we are using is my docker underscore id slash. Basically we can copy it from the last build. So this is the image. Since I already have docker id there, I will just copy custom HTML. All right, so we want to basically now run that image. It is being run on the background. So if we say docker container list or docker container ps, sorry about that, docker container ps. Okay, we don't have any ps, so let's say lx dash dash all. And here we have nginx running. And then we have a problem. It says exit status is 1, which means basically something did not go right here. And also we don't have any port being allocated here to run that. Okay, so let's try to debug that. First thing I'm going to do is to remove this container. So I'm going to say docker rm. Let's start by saying container rm and then the container ID. And this time I'm going to say docker container run. Okay, I don't want to run it in the background this time. I want to publish it to port 80 column 80. And then I'm going to give it a name. It's called custom HTML. And that is going to be from our image. So I'm going to say docker underscore id slash. So that should basically be custom. Okay, so I actually have forgotten the image that we used, but I could scroll up and just grab it from here, custom HTML, and then paste it here. And then we're going to try to run this again. All right, so you see here that I made a mistake. So this is why this container is not being able to run successfully. See, unknown directive daemon. So I'm going to quickly correct that and see. That should be basically DAE, not the other way around. So it should be DAE. I'm going to save. And once we do this, we then need to rebuild the image again. So I'm going to look for the command docker image build, and I'm going to call this 1.1 and successfully rebuild that image. And then we can then run our command now in the background, which I think everything should run successfully. Okay, so port 8080, and we can use the initial command. Okay, so the name is already being used. Okay, so the reason is because we did not delete that container. We did not remove it. Okay, so right now this container should be running in the background. Let's see if everything works as expected. All right, so it's up for 9 seconds and we can see that this is being run on port 80. And what we now need to do is to basically open a browser, or we can say localhost. So if I go to localhost, I should be able to, Okay, so this should be HTTP, not HTTPS. All right, you can see running Docker app, which is what we have inside of here in our HTML file. So let's do something else, and then let's create a PHP file. So we're going to say index.php, and right here I'm going to have an opening PHP tag. And basically here we also just want to echo out some stuff. So we're going to echo I am running PHP from Docker. All right, and I'm going to save that. And we're going to come back to our Docker file, and instead of HTML, we are going to say, let it be PHP this time. Just put it in this folder called HTML, doesn't matter. And then we come off to our command line again. We're going to have a new build. And this time, we're going to call this 1.2. And we are going to name this PHP. Okay, so but the problem with this now is we are already using this port, which is port 80, to run that other container. We can shut it down, or we can try to use 8080. Okay, that was a little bit too fast. We needed to rebuild the image before we can basically. So let's call this PHP, okay? So custom PHP, and then we're just going to rebuild that image. And now we can try to change this to custom PHP, and we run this on port 8080. All right, so that is running right now. So we're going to launch the browser again. Let's start with http :// localhost://8080. So if everything goes well, we should basically see that PHP is running, but we don't see that here. We see the default nginx page. All right, so we can do a little bit of debugging right here. And to debug this, we basically need to go inside of this container. So let's say docker container ls --. Let's start everything that we have here. So this is the PHP container that we have here, and this is the name. So we can basically say docker exec -it, and then we can specify the name, and we can run the bash command. Okay, and right here we can do an ls. Come here and then just say cd to go to home directory, and then cd here, and then do an ls. Okay, so we have index, and then we also have index.php. Let's say cd dot do an ls. We may need to check the nginx image to see how to where to basically put our PHP file, or if we need to basically create some other files to be able to run PHP. So what we can do again is to come to Docker Hub and then search for nginx. So we are using the latest one. Let's come down here. And basically, I don't think PHP is here. So there is no PHP here. That's why it's not able to basically run or execute the PHP code. So we can verify that by typing php-v here. You see PHP is not found. So PHP is not installed inside of this nginx container. Right now, we know that we have an issue. We cannot run PHP inside of this Nginx image because PHP is not installed in this image. So what we now need to do is to go to the big one where we are going to set up PHP for local development. So I'm going to basically close off all of this, and we are going to delete all of those containers and also the images that we have. So I'm going to close this. So the first thing I want to do is to get back here to the command line. I'm going to exit, and I'm going to basically stop all of the containers that are running, and I'm also going to delete all of them. So I'm going to say docker stop, and then we're going to use this one liner to just stop everything. So we're going to say docker process -a -q. So basically what we are doing here is saying print out all of the IDs of the containers that are running and then pass them over to the stop command and just stop all of them. So I'm going to hit enter, and it's basically just stop all of these containers. And we're going to do the same thing, but this time we're going to change stop to RM. So RM means to remove. All right, so we can say docker container ls --all. All right, so we have right now nothing. So what we now need to do is to build up our basic image like we've done previously. By now we're already familiar with how to do most of it. So we want to create a PHP Docker image that we can use to run any PHP application. And for the purpose of this tutorial, I'm going to be installing PHP 7.2, which you can install any PHP version that you need. I've not yet tried that PHP 7.4, and I didn't also use PHP 7.3 yet, so I will be sticking to PHP 7.2 for now. But I think pretty much any PHP version that you want to install, you can basically just install that one. So let's get back again. We're going to do all of this inside our custom application. So I need to get to the source code. And right here, I'm going to delete this HTML file. And we're going to leave just the PHP file here. Usually what I like to do is to have some kind of folder structure. So right here, I could create a different folder and call this folder nginx. So I'm going to put the stuff related to nginx here. And then I have my Docker file in the root of the project. And then right here, what we want will be an Ubuntu image. So I'm going to say I want Ubuntu, and let's give it a tag 18.04. Okay, so we just ensure to check the spellings correctly. Okay, so a few things that we can do here is to also create a label. So we can say label, and then we want to say who is the person maintaining this. This is just in case you want to check this into GitHub or something. So we can specify the maintainer for this image. And I'm going to basically put my name here and say Terry. Oh. Next, we're going to say env. Let's call this Debian underscore front end. And then set this to non-interactive. And then we're going to see some few commands that we have not seen before. The first one be the run command. And then we are going to say which command we want to run. So on Ubuntu, we can use apt-get to basically say we want to perform an update. And when we are running a command, in writing command to be run on the Docker file, we can put this / and then go to a new line, and we can chain on to different commands. So we can say after executing this first command, we also want you to execute the next command. So this is very important in order to make it more efficient, because whenever we use the run command, a different process is going to be executed. So if we have multiple run commands, so it's going to be creating different builds for each of the run commands. So if we are able to group all similar stuff in one run command, then it's more efficient. So I basically have all of these typed out somewhere. I'm going to just copy them and paste them right here. So I'm going to grab the stuff that we want to install. So don't forget, we're trying to install PHP. So we're basically saying here that we want to install PHP. The first thing that we are doing is to set up our Ubuntu environment, set up the time zone, and then we are installing some dependencies for PHP. We're installing coil, installing zip, unzip, git, supervisor, SQLi3. So some of this you may not even need to install. If you don't want, you can remove them. But like I said previously, we are trying to set up or build a PHP image that we can use to run any PHP project. So for any PHP project that you're running, this will be like the basic things that you need. Like you need Composer right here. We're installing Composer right here. And you need some other basic extensions like sdebug, soap, mbstring. So we are also installing all of that right here. So there might be some few tweaks that we can actually do to this, but that will be beyond the scope of this tutorial. We just want to see the basic use case for Docker. Okay, so going to close this. It was just installing that extension for me. And then one final thing that we want to do here is to use the add command. So we're going to say add ngns. So remember the folder that I created here. All right, so this one. So I'm going to say add a file from this folder, nginx/default. Let's call this file default. Take it from this folder and put it inside of the site available directory inside of nginx. So, or inside of our Ubuntu operating system rather. Okay, so what we are doing here is copying the content of this file which you have not created and then put it inside of here. So we're going to now create the content of that file. So save this. And then inside of nginx, I'm going to say, let's create a new file here called default. And inside of default, we are going to just put some basic stuff. So we're going to say 7. And then we're going to say listen on port 80. And then call this default server. Okay, so you can pretty much grab most of this information online for Nginx. It's pretty standard stuff. So we're going to specify the root. So we're going to say the root should be var/www/html. And if you're running like a framework like Laravel Symfony, then you may need to say it's going to be public folder. So you can say this is the root public. But right now we're just running a basic PHP application. So we can say put it inside of here. Okay, so that will be HTML, just to be consistent with what we did previously. And then we're going to specify the index file. So that should be index.php. If you also want to use HTML, you can also say index.html. And you can also add HTML. So if you're using Python or whatever language you're using, that will correspond to the index file that you want to basically use here. So I have specified that we can support up to 3 index files: PHP, HTML, and HTM. Okay, so we're going to say server underscore name. That should be underscore, and with a semicolon, and we can also set a child set. So these are pretty much basic engineer setup. Like I said before, if you already know how to do this, you can just quickly go ahead and update your file and continue to the next lecture. Okay, so basically we can stop here. Okay, or we can continue to add some few more stuff. So instead of continuing to type, I'm just going to grab this stuff and then just put them here. Okay, so we don't necessarily need all of this stuff for the purpose of this demonstration, but it might be things are useful to you as you develop your project. So I'm going to save that, and we already specified that we want to copy default to site available defaults, and we are right here inside of engineer saying that we are running on port 80. We're listening on port 80. Okay, so what we can now do is to build this new image. So I'm going to clear this up, and then we're going to just try to grab up the command that we used previously, build. Right now we're going to, yeah, we could leave this as custom PHP, and then build the image. If everything goes correctly, we should be able to build this without any errors. Okay, so the image is building. It's going to take some time to basically build the image. And now we can type docker image ls. And you can see all of the images that we have here because we now have a custom PHP. We did not delete the images. We only deleted the containers previously. Okay, so we have this Tedia 07 custom PHP, and we have the old one here too. So we can basically just delete these ones. So we can copy a couple of IDs and just paste them here and delete all of them at the same time. Okay, so let's paste this here. And we deleted all of that, so run ls. Okay, now we are now going to start up a container. So we're going to say run -d, and we want to publish this off to, let's say, publish. Let's map port 80 to port 80 inside of the server, and the image that we want to run is Tedia custom. Let's see if we can basically run it like this. Colon 1.0. All right, so this is running in the background, and if we say docker container ls, we don't see anything. Do we have any process running? We can do ls -o. Okay, so that should be ls, not la. Executed with the status of 0, and the command that was attempted to be executed was bin bash. Okay, so right now we do not have any default command that is running. If we again go inside of our code in the Docker file, right here we don't have any command that is being executed. So we just basically copied stuff to the image for Nginx to run properly, we installed PHP and all of the things that we need, but we are not running any command by default, and it attempted to actually run bin bash, which actually exited with a status code of 0, which means everything basically works fine. So what we now need to do is to be able to run PHP and Nginx at the same time. And for that, we are using this tool called Supervisor. So Supervisor basically manages this different processes for us at the same time. So we're going to create a script, and then we are going to basically use that script to run the different process. Okay, so let's come in here. And then right here, I could put it inside of Nginx just because I don't want to create so many folders. And maybe we can then rename this to something else. Let's just say Docker. Let's say Docker. Then also here, I will rename it to Docker. And inside of Docker, I want to create one more file, and I'm going to call this supervisor. So .conf. Supervisor d.conf. Okay, and basically this is a configuration file for supervisor. We're just going to put some basic code in there and get things up running. So, and this is how we basically started. So you start with open a square bracket, type in supervisor d. We are just going to ensure that we're checking spellings. So we're going to say no demo should be equal to true. And then basically here we are going to say program that we want to run. Let's call this nginx. And then we can, the command should be nginx. Command is equal to nginx. Okay, we just ensure that we are checking the spellings correctly. nginx. And then we're going to put some basic stuff there, like printing out errors and how errors should be logged to standard output. So copy and just paste all of that there. And then I'm going to basically do the same for PHP. Okay, so we're using PHP FPM, and I'm going to paste that of PHP here. So basically we are saying this is a command that we want to be able to execute, and also we want to log our log files to be sent to standard out. So we save supervisor D, and then we're going to update the image. So let's copy this, paste it here. This time this should be supervisor D. I thought I saved that as supervisor d.conf. Yes. So that's basically supervisor d.conf. So we need to type it out correctly. That's inside Docker. And we want to copy this to a different location. So the location that we want to copy this to also be in etc supervisor conf.d supervisor d.conf. So we're basically going to replace the file that we have here. And then the last thing that we need to do is to specify our default command. So we're going to say cmd, so which is the command that should run when this container is started, or when a container is started using this image. So we're going to run supervisor D. So I just want to be sure that I am getting the name correctly. Okay, so save that, and then we're going to build a new image. So we can basically delete this one. So I could say docker stop, then just re-execute that command. and then docker rm. All right, so these are commands that you need to be very careful with when using, because I'm doing this because I don't have anything important run that I've created using Docker on this machine. This is a brand new computer. So if you are issuing any of this command, you need to be extremely careful how you do that, because it basically remove all of the stuff from your computer. Okay, so we're going to build the image again. We could say Docker image build, or we could also say Docker build -t. Okay, so this is also a different way. When we say -t, then we need to specify all of the other stuff that we specified previously. So let's use the one that we're using before. Okay, so we build with this image and with this tag. We have this image existing, so let's make this 1.1 custom PHP. And then we're going to run that off of a container. So we're going to say docker container run. So spelling of container is not correct. Docker container. Okay, so we want to run 1.1 on port 8080. And then we can say docker container ls. All right, so this is now running on port 8080, and we can see that the command that is running is supervisor D. So if everything works correctly, we should be able to basically see PHP. So let's see. Let's go to the browser, http :/local host. Okay, so it says 403 forbidden. So this is because we don't have any PHP file inside of the part where Nginx is listening. So if we come to server default, we say that it should be right here. Okay, so this is the root of our project. So what we need to do is to just have a one-liner here. And what we want to do with this is to say add. So we could use add or we can use copy. So it's basically the same. Okay, so we can say add index.php to this part. And I'm going to build that image again. Okay, so let's call this 1.2. We have the image for 1.2. Let's stop the running container. So we're going to say docker container. And we want to stop this so that we can reuse port 80. Stop this container. And we can just also remove this container. So let's say rm. And now we can rerun that command again. Docker container. Okay, so that will be 1.2. And we basically need to reload the browser. And now I am running PHP from Docker. All right, so everything works as expected. Let's attempt to update that file, the PHP file that we have here. php_info. And there should be a function called php_info that basically prints out. Let's put a line break here. Let's save this and see if we are able to get it to reload from the container. All right, so it's not reloading, and the reason why it's not reloading is because we basically copied the file to inside of that container. So what we should basically be doing should be to sync our file. So instead of copying the file, we just sync it so that when we update the file on our local machine, it is also being updated inside of the container. So let's see how we can quickly achieve that. All right, so the method I'm going to show you is really going to be simple. There are other advanced ways for us to basically sync the files from our local project to inside of our container using Docker Compose file, which allows us to do a lot of stuff. But we're going to really do the simple stuff. We're going to just use the mount command to basically mount the current directory that we're working in to where we want to serve our files from. So let's come back again to tested details. So we have this code here and we have a Docker file. I'm going to basically just remove this. Okay, so when I remove that, and then I'm going to build a new image or update the existing image. So we can do like so, but this time we're going to add one more option here. So let's say first of all we stop the let's stop the container. Stop the container so we can basically grab this ID. This should also be able to stop the container. All right, so that container has been stopped. If we reload here, we get cannot connect. Looks good, and then we can try to re-execute or to rebuild that image. So we're going to say Docker image build. Okay, so we just going to update that image that we already have before, and then now we're going to run that in a container. So let's run that image, but this time we want to mount the current directory. So we can say dash mount, and then the type is a binding. So we're going to bind this working directory, okay, to the folder inside of our container where we want to run our source code from. So we'll say bind, and then we specify the source. So for this we can print out the current working directory. So we use a $sign. Okay, so just the same thing when we printed out the name of the containers that we wanted to delete. So $sign, and then we type in the command pwd, which is to print out the current working directory. So it's going to take everything inside of our current working directory and then map it off to a target that we specify. So we need to specify the target. So we're going to say target, and the target should be the folder. That should be /var/ww/html. Okay, so we need to just verify that. So let's come back here and look at default var www HTML. Okay, so that is the right folder. We are binding both of them together right now, and then we want to specify the image, and that is up and running. So we can say docker container ls --o. All right, so we see that it's basically running port 8080, and it's up for about 12 seconds now. So let's try to reload on the browser. So right now what we have is our source code is being mapped onto the image that we are using to run a container. So let's try to make some changes just to verify, because I think it's basically running an old image. So maybe we should rebuild. So I think that command was php info. I think I was typing the wrong thing. So let's save, and then do a reload. If it works, then everything exactly. So now once we update the file, we are automatically seeing the changes. This is because now we're using a different command, which is basically mapping, okay, or mounting our source directory, which is where our source code is. So wherever your source code is, you just need to specify it right here and then specify where it should be mounted. So this should correspond to the root directory that we specified inside of where nginx is listening. So this is the root directory, which means that the content that we have here are the content that will be saved when a request from port 80 comes to nginx. Whenever we update now inside of the source code will be automatically updated on the page. So we could also say I'm running Docker container, updated image. And when we save this, we still get the updated code now running here. So let's reload, says. All right, so this is really basic stuff when it comes to Docker. And as I said at the beginning of this crash course for Docker, we are going to basically be learning a lot about how to use Dockers. So as I continue to create new courses, I will be strictly working on Docker environments, and also maybe have a basic setup for people who are using who cannot use Docker on their machine. So all of the source code here, or rather the source code that we have here plus an updated version, will be available on GitHub, and you can also see the link to download it from the description of this video, so that you can basically use it to run off any of your PHP application. All right, thank you for viewing. If you like my videos, please subscribe and click the notification bell so that you get updated when I upload new videos.